Hello, welcome to the wonderful world of random sequencing. Also, I have a channel, another channel called Sequencing Random Numbers. On this particular channel, I deal a lot with SuperLotto Plus. And to understand random sequencing, you have to understand certain concepts. And one of them is binary numbers. The binary number is like, for instance, the this would be could be considered a binary number 1 1. The 1 1 is equal to 3, so that could sequence to a 3 potentially. Binary decimal numbers, those are a combination that are half binary and half decimal. Now, for example, here's the 1141. Now, the 1141 sequence forms 47. So if you get 11 or 41 or 41 to 11, that could sequence to a 47. And the reason why is because this 111 forms a 7 in binary notation linked to a 4 that forms 47. So that could sequence to a 47. Now, another concept right here is virtual numbers. Virtual number, for instance, let's say you get a 27 and it sequences to a 36 that's nearby. It could be next door, or it could be above half step. Yeah. And so that could sequence another to a 36. And what it does is that, in other words, 36 plus 36 is equal to 72. Now that 27 can represent a virtual number. In other words, it could represent itself as 27 as well as 72. And in 72, when it sequences this right next door to a 36, then it could potentially become a virtual number, which could be the reverse sequence of what 27 is, and that's 72. And 36 plus 36 is equal to 72. There's also the concept of metamorphic numbers. Metamorphic number, for instance, the 11 8. And what you do is this 8, this 8 has double zeros. In other words, to make an 8, you need a 0 0. And so if you put that underneath the 11, it forms another number, and that number is a metamorphic 6. The 1 linked to a 0, that's a metamorphic 6. And then this 1 linked to another 0, that forms another metamorphic 6. So what you have is 6 6. And 6 plus 6 is equal to 12. So this could sequence to a 12. It could sequence to a 26, because the 26 carries the statement 2 6s. What is 2 6s? 6 6. And 6 plus 6 is equal to 12. So that's the concept of metamorphic numbers. You got statements and expressions. Now each number can carry its own statement. In other words, like the 29 carries the statement 2 9s. What is 2 9s? 9 9. 9 plus 9 is equal to 18. So that could sequence to a the 29 could sequence to a 18, or the 18 could sequence to a 2 9, or the 29 could sequence to a 9 9 sequence. So you also have anatomical numbers. Anatomical number is what, like the 17 4. That's an anatomical number, and the reason why is because if you look at the 17, it looks like an upside down 4. 4 has all the elements of creating a 4, and so that's that. There's also the bridge numbers. Bridge numbers help to bridge sequences, and those are the 11, 13, and 14. I give them names, like this is the equals, this is the I am statement, and this is the I form statement. So these help to create and connect sequences. You also have count numbers. Count numbers are repeat count numbers. For example, now if you were to look at this number right here, notice how you got the 13 and 15, right? And so the digits to the right hand side, they form 35. And these to the to the left hand side, that just a statement of equality. In other words, the 1 1 is the equal sign, equal statement. Equals what? 35. So if I want, let's say this number right here, you see that 5, and I want to know if a 35 might be played out, because over here, notice how you have that 3 and 5, that forms 35. And that once you see that 5 there's already a question mark. You're going to say, is it possible that 35 is going to be sequenced? In other words, it's going to put a 3 5 to make 35, right? And so what you do is, this is what you call the root of 35. This is the part that starts off with 3 5, right? And so what you do is you count the distance between this cell and this cell, right? And if whatever that is, in other words, if you were to count, this is 6 and another 6, that's 12, 13, 14, 15, 16, 17. Now, if you see a 17 nearby, that tells you that that's the count number. The distance between this number and this number is 17. So this is what you call a count number. And so the thing is that when you see that 15 and you see the 13, that could potentially create a 35, right? And so what you do, you assume the 3, and then you count the distance between here and here. If you get 17, then that tells you that the count number is 17. To repeat a 35, that is. I'd like to talk about the concept of how these numbers are formed. Like, in other words, I showed you how the 35 was formed by the 13, 15, right? Same thing with the 12 or 19. Now, if you look at the digits to the right-hand side, you form 29, right? And this is basically the equals statement. Equals what? 29. So if you go over here, notice how you do have a 29. Now, that 29 could play out itself as 29, or it could play itself out in an extended form. Now, that's probably the way you would probably want to imagine it, because this number, the 12, 19, that forms 29. The sequences to the right-hand side, they have sequential potential. So this is 29 right here, right? And so you're wondering, is it going to play out a 29, like as a repeat, or is it going to do it in an extended form like that? Now, if you imagine it that way, you would have got these two cells. Same thing with this. Now, the 29, let me explain what the 29. The 29 carries a statement 2 nines, which is 9, 9. And 9 plus 9 is equal to 18. Now, notice how you do have the reverse 8. You have 81. Now, that could be seen as 18 as a reverse number. And if that's the case, it could sequence to a 29, because the 18 is equal to 29, right? So what you have is the same thing that happened over here. It created this form of 29. Same thing happened over here. This form is 29, and that's equal to this reverse 18. I kind of jumped the gun here, and I wanted to explain that these numbers here, these calendar dates, they're very important. They help to create the sequences and even the ticket numbers. And I kind of jumped the gun on this, and I should have explained that to you, that these have sequential potential, and they help to sequence these numbers right here and create these numbers. So it's very important to understand that relationship. There's this synchronicity between human behavior and what we calculate and project, and all these calendars and how we set that about. They have a direct relationship with the sequences that are happening at any given moment. So it's important to understand that, and then so you could translate these sequences by knowing that. Now I'm going to explain the number 27. The 27 carries a statement 2 sevens, which is 7, 7. 7 plus 7 is equal to 14. So 14 could sequence to 27, and a 27 could sequence to 14. As you can see over here, notice how you have the 7, 2. Now that 7, 2 is could translate to 27 as a reverse sequence. And as you notice over here, look at the ticket number right there. That's 7, 7. 7 plus 7 is equal to 14. And it's also equal to this 27, because the 27 carries a statement 2 sevens, which is 7, 7. And that's equal to 14. So if you will go over here, notice how you have a 4 there that's created, right? And you know that this sequence is very powerful. And so you're wondering, what is the possibility of this number? And so because of the algorithm that's being played out here, the 27, and that's equal to 7, 7, and 7, 7 is equal to 14. And as you could see, now, you could assume that it'll play out a 1 to make 14. And if you do that assumption, you might as well, because if this 17, because you already formed 14 here, assuming that that's going to be a 1, right? So you might as well play out 27. And in this case, look at that, it played out 27, and it played out 14. and the 7 is equal to 14, and this is 27 in reverse mode. It played that right there. You see that? Whenever you discover that you're the mode or the theme that is being played out, in other words, we already talked about this 72, which could represent itself as 27 and how it relates to this 7-7, right? 7-7. So this is a theme that's going to be played out repeatedly, you know, and it does it in different forms. In other words, another way of making 27, if you have a 12, knowing that the 12, one way to make it 27, you can do it with the 17. In other words, a 12 linked to 17, that could form a 27. But another way is this number, 11, and the way it does. So there's the 11 and here's the 12, right? And so this 111, that forms a binary number. That's number 7. 111 is 7 linked to a 2. That forms 27. So this environment is being played out. It's very strong. And so another way it create like say 14 is that if it has a 4 right there, right? Because this represents 27, so it has a 4 right there. So there's a good possibility that it'll play out a 10 to make 14. Because this particular algorithm is very, very powerful and it's playing itself out, you know, and it continues to play itself. Another way of making 14 is by a reverse. In other words, a reverse 14 makes 41, and that 41, you know, it could potentially sequence to a 11 sequence, because this carries a statement 4 ones. 4 ones is 1111, so it could potentially sequence to a 11 sequence. Another way it could create itself is by this sequence right here, the 21. 21 carries the statement 2 ones, which is 11. So if this is equal to 11 and this is 11, that makes 4 ones. You see that? So, and this is but that 41 is also related to the 14 as a reverse sequence. Now I'm going to explain over here. Notice how you got that 75, right? And you got a 25. So there's a relationship right there. So the relationship is that if you get three 25s, that's equal to 75. So notice how this particular relationship created a 25 right here, right? And then it followed it with another 25. You see that? And so what you have here is 25, 25, 25, and that's equal to 75. You see that? I'd like to talk about the concept of 76. Whenever you form a 76, it could create a 38 sequence. Same thing with the 78. It could create 39 sequence. Now, if you go over here, the numbers, the digits to the right hand side, these big digits here, 7, 6, that forms a 38. 38 plus 38 is equal to 76. So there's a high probability that it could create a 38 sequences. Now you can see over here that a half step from this plot right here, that's a half step from here, right? 76, and so it created a 38. You see that? And then this 76 also right here, it created a 38. There's a 38 right there. Another number that could be played out is the 78. Now that 78 is right here. You see that? Now what is 78? 39 plus 39 is equal to 78. So if you look over here, notice how you got a 39 right there. See? And that's right here, 78. That's just a half step away. Now if you go over here, this number here helps to bridge this other 39. This is the 13. It's the I am statement. So you have 78, right? And then you have your bridge number, and it creates a 39 right there. So basically you have 39 formed right here. 39, and it's all linked to this sequence right here. I'd like to talk about the 22. Now, the 22 is can be seen as 2 plus 2, and 2 plus 2 is equal to 4. So this could be your bonus number. As you can see right here, you have a 4 right there. I'd like to talk about the number 25. The 25 carries a statement 2 fives, which is 5, 5. 5 plus 5 is equal to 10. Now, I want you to notice here, notice how you have the 25 right there, right? And so there's a possibility that it could sequence to a 10. And as you can see, it sequenced to a 10 right there. Another thing is that I wanted to show how this 11, when it sequences to a 10, it forms a special number. And that number is, this is what you call, it's part binary to decimal number. And so what it forms is 111, that's 7, linked to a 0, that's 70. And that 70 is equal to 35 sequence. And as you can see right here, you have that 35 that's formed right here. You see right there? And so it could create another 35 bit. The thing is that it created a 5 there, right? So now it has to form a 3 over here to create a 35 plus 35 is equal to 70. And what happens usually in a lot of cases is that this 0 will link to a 7, a number that has a 7. And this forms 70. So that's something that you should think about. I'd like to talk about this number here, the 24. The 24 carries a statement 2 fours, which is 4, 4. And that could sequence to a 44. So you can see that over here you have 24, right? And then over here it created a 44. I want to talk about this number here, the 4 and the 11. They form a binary. It's a binary to decimal number. In other words, the 11 becomes 3 in binary notation, and then linked to a 4 that makes 34 or 43. So it's possible that this number can sequence itself. Now, will it sequence as a 43 or 34? That's the judgment call that you would have to make. But in this case, it did a 34, and that's one reason why it created this sequence right here. And also another thing is that whenever you get a 34, it's quite possible that it could sequence to a 12. Now notice how you have a 10 right there, right? So all you have to do is just put a 2 right there, and you formed a 12. In other words, in this 12 created another 12 right there. So it's an active sequence, and it's all in relationship to that 34 right there, you see. And so it's playing itself out again by forming a 12 right there. Another concept I want to introduce here is the this number right here. Now notice how this theme played out, the 75, right? It created 25, 25, 25. Now the 1115, that forms a special number. And that 1115 forms, if you link those three, 111, that's 7 in binary notation. Linked to a 5, that's 75. So this number here forms 75. And that was the theme that got played out, right? 25, 25, 25, right? And there's your 75 also. This is how you make 75 in a binary decimal relationship right there. So that's pretty much it. We covered a lot of material. My channel, give me some thumbs up. Subscribe to my channel. I have a channel called The Wonderful World of Random Sequencing. I do basically a lot of roulettes on this particular channel. And then I do, this is the one I do Lotto. So this is sequencing random numbers. Basically I do Super Lotto Plus, but I think I'll be doing Fantasy 5. I like the lower numbers, you know. And so we'll see you in the next sequencing random numbers.